please don't feel put upon. I just didn't answer it for some reason. Sorry. But if you'd like to email me and take a shot, I'm Art Bell at mindspring.com. That's ARTBELL, ARTBELL at mindspring, MINDSPRING.com. Now, once again, on a secure satellite line from...
New Mexico.
You're in New Mexico.
Yes, I am. We're up in the northwest corner of New Mexico. We're at a secure facility here, and I don't like to give more information other than that. People can find contact information on our websites if they would like to contact us.
Okay, so people can get to you by email, that sort of thing.
Absolutely, yes.
All right. As of 5 years ago, you'd worked with plant life. You'd actually sent plant life, I assume, into the future. What about the past?
What about the past? Absolutely, yes. Art, could I ask you a favor? You had asked me a question just before break, and I didn't say probably one of the most exciting things. You had asked me about where research is happening. Could I make one addition to that before we transition?
Absolutely.
Well, for me, when I look at all the activity happening in the world today in time research, and this is why I'm so excited to be here, is not talk about necessarily what we're doing, what other people are doing. What's happening in India is absolutely remarkable. Their Ministry of Science and Technology in New Delhi and their what they call their DRDO, it's their Defense Research and Development Organization, they've set up a massive facility and project. It is larger in scale by a factor of 10 than anything else in the world on time research. And they're doing this. There's a district in the state of, it's called Maharashtra in India, in the Pune district, in an area called the Digi Hills. They have a massive facility, and what they've done is they've brought some of the brightest Indian defense research scientists and engineers into that area. And all the whispers among my peers around the world and physicists around the world is what's happening there. And we have a lot of activity in India because we have some facilities there. We also do most of our software development there for our support systems. But what's happening there, and I'd encourage your listeners, watch what's going to be happening there. It is absolutely phenomenal what they're doing, and they're going way beyond. The activity level we see in India is higher than anywhere else in the world today.
And any idea? I mean, after all, we have America, we have the large European nations, we have China here in Asia. Why India?
Why India? You know, it's a wonderful question, Art, and I wish I had a very profound and exciting answer for you. I think why India, it's only speculation on my part. If you look at their spiritual beliefs and the way they look at time in the universe, is very unique in the world. One of my favorite sayings when we're talking to college students around the world is to remind them, we don't see the world as it is. We see the world as we are. And that's very important. We don't see things the way they are. We see things the way we are. And what's beautiful about the Indian culture in their deep spiritual beliefs is they look at the world as a dynamic web of information and energy. They don't have these barriers in their, maybe as much in their human minds as citizens of other countries that, you know, they have to categorize time, put it in a little bucket, put a nice bow around it, and say it's defined and feel they understand what it means. They don't look at it that way, and perhaps that's the reason. And also, I think one of the other reasons, Art, and it's something I admire, if you take a look at countries around the world, there's only really one country whose presidents historically are leaders in the scientific community, and India is one of them. Presidents in India are elected based upon their achievements in areas of science. And I think that's why you see the explosive growth in India, as well as their, what I would say clearly is their dominance in time control technology today.
Of all the countries that you would expect to be, as you put it, dominant in time control technology, India. Wow. Can we come back to the TTD for a moment? I'm curious, with a nuclear detonation, I guess, kind of like a radio signal, you're able to pinpoint where a nuclear detonation takes place, not only by satellite, but by the tremors, the magnitude tremors that are generated in the Earth, and then a triangulation is made, I suppose, much like, well, you would for a radio signal, and they can determine roughly where the nuclear detonation occurred. Is it roughly the same with time travel or with time travel experiments when they go on?
Uh, Maybe not so much with time travel. You notice I've been using the word time control. Yes, matter of fact, I'd even say it's easier. With nuclear reactors, not only can you see a nuclear detonation and pinpoint it, our satellite systems today can even detect nuclear reactors that are starting up or shutting down, and different types of events on a very, very low energy level.
Right.
With a temporal tremor detector, it's a lot easier. Our ability to locate is not so strong, but to pinpoint, locate, but our ability to tell the level of activity and whether they're working with information or matter, in their experiments or their technology, and the level that they're doing it, is something that we can detect today.
Okay. This name that you've assigned to a temporal tremor detector. Now, tremor is the key word for me there. There was a movie, and I can't recall which one it was, in which there was something called time quakes. I'm sure you're familiar with that. In other words, once a paradox or something wrong was done in the course of time travel, it created a tremor or an earthquake in the fabric of space-time. Is that kind of what you're getting at with a temporal tremor detector?
Uh, yes, in some ways, yes. For me, yes. The short answer is yes, Art. But I also see a more important value. One of the things that concerns myself and many of my peers is how this technology is going to be applied. The consequences of misapplication of this technology are extreme and can be catastrophic if it's not managed well. What we're really happy about a TTD is that we can use it and its base technology to determine, um, generally where and to what level experiments are going on, which helps support transparency. For me, that's the most exciting element of a TTD, and also it lets us know truly what the state of the art is in, different areas or facilities doing this type of work. Could you use it as you say, has been used in science fiction and movies? I'm woefully not familiar with time travel movies, but um, could it be used for something like that? Yes, but more in the, if you will, in that moment, not so much looking towards the past or the future. What we're trying to do with the TTD is simply detect, disruptions in the fabric of space-time near, facilities where work is being done.
Okay, let me attempt a couple of questions. You mentioned that once this machine is on, you've been able to achieve a 300% increase. In other words, 1 minute in the machine, 3 minutes of time within the machine have passed compared to um, operational real time, however you want to put it. Can you tell me how far into the future you have at any point gone?
At this point, I did give you specifications on our 2002 results, which, obviously 8 years ago. Unfortunately, this is one question, I will tell you I can't answer, but I will say at least this, that at least two orders of magnitudes, higher in results, both, in time acceleration and retardation rates.
Wow.
We have, and I'm not trying to be secret of it. We do have partners, all around the world. We have private partners, government interests, and there's certain things that I do have unfortunately, an obligation, my word, not to share. But
Well,
hopefully,
that's all right. I told you I'd push as hard as I could. You just let me know when you can't talk about it. When everybody has always told me, including Professor Kaku, that if time travel is possible, travel into the future is substantially going to be easier than travel into the past. Do you agree that that is so or not?
Oh boy, I can't believe that I'm actually going to disagree with Dr. Kaku, because I respect him very highly. Actually, what we're seeing and we have been seeing for the recent years is actually we're seeing it more of an equal capability, and it has to do more with the nature of the technology that we've been refining. What we're doing is we're creating closed time-like curves, and for your listeners, what a closed time-like curve is simply, it's a term very common in physics, but it's a term used to describe how space-time can be bent in a way that time actually loops back on itself. And since we're generating closed time-like curves in our new systems, we're finding it equally as easy to move backwards in time as well as forwards.
Okay. Actually, that is very close to a term that Dr. Kaku used anyway. Uh, when I asked him theoretically about time travel, he said, "Well, not yet, but if it happens, here's how it might happen." And he was talking about folding back space-time and sort of jumping across. And so theoretically, that's how he imagines it might occur. And don't worry about disagreeing with him. In about 4 or 5 instances, things that he had chuckled about a few short years ago, and I've been interviewing him for a number of years, he now no longer chuckles about. In fact, a great number of scientists are working in these areas that were chuckles some years ago. So we don't so easily dismiss anything at all, nor does he anymore. He used to. He used to laugh at the stuff, including UFOs, the possibility of life elsewhere, and all the rest of it. He laughed pretty hard at that. No more. No
By
more.
the way, your show 2 days ago was absolutely wonderful with Dr. Kako. I enjoyed it immensely, and I'd encourage your listeners to get on Streamlink and listen to it. It's always a pleasure to hear what he's up to.
Yes, indeed. All right, you mentioned that there's so many directions for me to go, I don't know where to go, but you mentioned a few moments ago that there were some pretty dire possibilities if there was a mistake or misuse of this technology. Help me out here a little. What can go wrong?
Oh wow! If we look at the